All right, we're gonna start off here on 1 and 2. I'm gonna just call this a trinomial to start, and this is kind of answering part B. So trinomial just means there's three terms, 1, 2, 3. Next thing I'm gonna do is part A is the degree, and the degree is literally the biggest exponent. So I see that that's a 5. And then the leading coefficient is always the number in front of the biggest exponent, and so that's this number up here, which is actually an invisible 1. All right, next up, multiplying these radicals. So we multiply the outsides first, and that gives you negative 16. On the inside, we are technically going to multiply these, but I actually just leave them separate multiplying because I'm going to break them down anyway. And then I'll do x to the third since that was x to the first and x squared. So now I'm going to break this down. It's 7 and 5, and then this one is 7 and 6, which breaks down to 2 and 3. And then for the x, I have 3 x's there, so I'll write it 3 times. So now I'm going to find some twins here. So it looks like I got twin 7s and then twin x's. Now I already had the negative 16 out front, so I need to send a 7 out front. That'll be multiplying, and then an x as well. Remember, when the twins leave, they leave as 1. And then I have a loner 5, 2, and 3 here, so they're going to go back in the house. And a loner x, which is going to go back in the house as well. So now I have to do 16 times 7, which is 240, and then 11. So negative 112x times the square root of, and this is 10 times 3, which is 30x. All right, next up, number 6. So we're going to rationalize the denominator here. Although the first thing I want to do is reduce this. Anytime you can reduce the top and the bottom inside the radical, you're allowed to do that. So it's going to be 4 rad 2 over radical 3, because I just divided them both by 5. Now I need to multiply by rad 3 over rad 3 to top and bottom. Now that just multiplies inside the radical. So it's going to be 4 radical 6 up top. On bottom, it's radical 9, or it's just a regular 3. A radical times itself is always just kind of that number, but no longer in the radical. So there's my answer. Oh, you should actually check if you can reduce these numbers outside. In this case, you cannot. All right, next up, number 8. So this one I'm going to take care of the parentheses first. So the negative 3 multiplies by all of the exponents inside. Now we have a lot of missing ones here, so I'm just going to add a 1 in there. So everything's going to get multiplied by negative 3. So it's become v to the negative third, u to the negative third, v to the negative 12th, and then 2 to the negative third, and then this one will actually be v to the positive 12th. All right, and so next up, I'm going to move all my negative exponents. So pretty much everything's getting moved except for this v to the 12th on bottom. That was the only one that was positive. But now I'm going to have another v to the 12th on bottom because I got to move that one. I'm going to move the v to the third to the bottom, the u to the third to the bottom, and then the 2 to the third to the top. Okay, now I don't have any battles going on here, so I just need to combine all my v forces. So I'm adding up all of those. I'm going to keep the u the same. V is going to be 15 plus 12 is 27. And then 2 to the third power is 2 times 2 times 2, which is 8. All right, next up, number 10 here. So this one we're just going to distribute. And whenever we do this, we always multiply the regular numbers but add the exponents. So 6 times 7 is 42, and then I add the exponents would be 4. Next up here, 6 times negative 6 is negative 36. I'll just remind myself that that's the first power. So that's going to become b to the third. And then this one, 6 times 8 is 48. And then the b really has nothing to add to, so it's just going to stay as squared. All right, these ones we need to distribute again and then combine like terms. So this one I'm going to distribute 7n. So times 1 is just going to stay the same. 7n times negative 1n. I'll just remind myself that that's really a first power here. So 7 times negative 1 is negative 7. And then 1 plus 1 is my new exponent of 2. This one I'm just going to distribute the negative 1. Really all that does is it changes all the signs. So they're all going to flip. And now I need to combine like terms, so I have negative 7n squared and then negative 1n squared. So now we're not changing exponents anymore because we're adding. Before we were multiplying, so when we add, we just add the numbers in front and then keep the exponent the same. And then, so then next up, I got my 7n and my negative 4n, so it's going to make a positive 3n. And then the 1 kind of has nobody to combine with, so that's just our answer. All right, next up, number 14. So these ones we need to distribute. I want to kind of remind you, I want to keep these two sides of the equal sign separate. So I'm going to distribute and combine like terms on each side. So this will be 48 minus 24r, and then minus 3r needs to distribute. So that's actually going to be plus 12r, and then minus 9. Then we'll combine those like terms. So negative 24 plus 12 is negative 12r, and then 48. Actually, I'll color code this. 48 minus 9 would give me plus 39. Now on the right side here, I can just combine these two and I just get 1r. Now I always want to get all my variables are on one side, and so since I have numbers on the left side already, what I'm going to do is I'm actually going to add the 12r over to this side. And so I get 39 equals, and this will actually be 13r. And then since I have a number multiplying by r, I'm going to divide that over to get rid of it. And so r equals 3. All right, same idea here on number 16. So I'm going to distribute this 7 here. Now I can't forget about that 4. It's not going to change, but I do still need it. So then that'll be 7n minus 56. And then over here, I got a negative 5n and then minus 40. And then we'll keep that 8n out back, although it's not changing. Now I'm going to combine like terms. So in this one, it's I'm going to keep the 7n the same, but 4 minus 56 is negative 52. On this side, I'm going to combine my 5n, my negative 5n, and my 8n, so that gives me 3n minus 40. So now I have variables on both sides, so I want to get them all on one side. So I usually move the smaller one. So I get 4n minus 52 equals 40. Oh, negative 40, excuse me, because that was negative before. So then I need to add my number over to the other side. So I'm going to add 52 to both sides. So that'll give me 4n equals, and this is, it's actually 52 minus 40. And so that's 12. And then we'll just divide by 4, and n equals 3. All right, next up we're going to solve this one by elimination. So I'm going to eliminate the x's by multiplying this by negative 3. That's going to give me a positive 9x here, which I see is going to cancel with the negative 9x that I already had. But I do need to distribute this in here, so this is going to become positive 12y and then negative 12. And then I'm just going to rewrite this one as is. So I'll cancel these out, and actually everything cancels out, so I'm left with 0, 0. And then on that side, it's 0 as well. And whenever that happens and all the variables cancel, if you get a true statement, then that is infinitely many solutions. So that's what we have here. If it says 0 equals 1, that would be no solution. All right, next up here, we're going to find the product. We're going to multiply these together. So there's two main methods for this. You can use FOIL or you can use the box. I kind of prefer the box, so I'm going to go ahead and use that. So on the box, you just build a 2x2 box here. We put one of these up here, and then one of them along the side. It does not matter which one you put where. And I multiply now to fill out the box. So I have 4b times 3b would be 12b to the second power, since we add those exponents. 4b times 1 is going to give me just 4b. 3b times 2 will give me 6b. And 2 times 1 will give me 2. Now I'm just going to combine like terms to leave the box and write my final answer. So 12b squared has no like terms, so I'll write that down. 6b and 4b makes 10b. And then the 2 also does not have a like term, so I add that out back. All right, next up, number 22. So same idea here. Once again, if you want to use the FOIL method, it's first, outer, inner, last. But I prefer the box here. So you get negative 8x, and then you get negative 3, and then positive x and positive 4. Once again, you can switch those if you want. It does not matter. But we'll multiply to fill out the box. So this one will be negative 8x to the second power. And then this one will be negative 3x, and then negative 32x, and then negative 12. So then I have this one right here as negative 8x squared. I combine these two in this case, and in most cases, and that's negative 35x, and then I have the minus 12. All right, last up here we have a 3x2, so we're still going to use the box, but we're going to use a 3x2 box so that we can fit this whole thing up here. And then this one's going to go down the side. So then in this first box we get 14n to the third. And this one we get negative 7n squared. I just want to get 14n. So we're multiplying kind of all this and this to get there, this and this to get there, this and this to get there. Now we'll do the same thing here. So then this will give us negative 10n squared, and then 5n, and then negative 10. So now we're going to combine like terms. 14n to the third has no like terms. These two will combine here to make negative 7n squared. These two will combine to make 19n. And then this one's negative 10. So that's it.